Hello students, and welcome to another exciting edition of Pre-Lab Videos. So today's video is for the lab entitled Two-Dimensional Motion. So if we had a particle like this, and we were to shoot it off a cliff in the horizontal with some constant initial velocity, as you know, it would move along a curved path like that until impact. And for us, we're going to ignore air resistance and always be near the surface of the Earth. So for that reason, the only acceleration the particle will experience is in the vertical dimension due to gravity. There will be no acceleration in the horizontal. Therefore, the horizontal component of the particle's velocity will always be constant. And in today's lab activity, you should be able to verify that fact. So if we knew the launch point and we knew any other point along the particle's path, we could determine the velocity, horizontal and vertical components of the velocity at that particular point. If we had other points along the path, we ought to find that the horizontal component of the velocity is the same at all those points. And this setup will allow us to do that exactly today. So we should be able to determine several points along the path given an initial launch velocity and prove that in fact the horizontal component of the velocity is constant. So it's a very simple setup. You'll need a lab stand like this, and you'll need this little platform that attaches to the lab stand, a little ramp like this that launches the ball. It's what gives the ball a particular initial velocity that is always the same. You'll need a little C-clamp, you'll need some tape, and you'll need some carbon paper, good old-fashioned carbon paper, and some regular blank paper like that. So what's going to happen is you will attach the ramp to the platform. So I'm going to do that with your C-clamp. I'll do that right now. And as you can see, you have to be near a wall with the setup to carry out this little experiment. So I'm very near the wall there. And you want to have it set up so that after the particle is launched, it strikes the wall, well before it would reach the floor. So I will check it out here. Obviously, it strikes the board somewhere in there, or my wall right there. So I'm going to have this point of launch, and then I'm going to be able to make and record the point of impact right there. So I have the point of launch and a point along the curved trajectory there. So the way we will determine the point where it struck the wall is with the carbon paper and the blank paper. So you want to take your blank paper like this and put the carbon paper black side down and affix it to the white paper with a little tape, just something to hold it together. And then I know approximately where my ball was striking, so I'm going to put the paper on the wall in that general area there. So I'll use a little tape to do that. I'll place it right here, pretty well in the vicinity of where the ball was striking the wall. That ought to be good enough. I'll put one more piece on it to make sure it's good and firm. So we're ready to begin the experiment. The first thing we need to do is, you'll have a level to do this. I'll just kind of approximate. You want to go from the point where the ball is launched perfectly out in the horizontal with a level and make a mark for that on your paper here. So I'll make a horizontal mark there on the back of the carbon paper, and it should show up on the blank paper on the other side. Now I'm ready to begin the experiment. I will measure the distance between the wall and the launch point right here at the edge of the ramp, and I'll record that distance. And then I will launch the ball, and it should strike and hit the carbon paper below that mark and leave a mark for us on the white paper. So let's do that right now. Boom. And we have it, it's somewhere down about right there. I'm going to repeat the experiment by increasing the distance between the launch point and the wall by moving the stand out a little bit. I'll go back. I'll measure this new distance from launch point to the wall. I'll repeat the experiment. I should get another mark slightly lower from my first original mark here at horizontal. I'm going to do it a third time. I think it's best that you do this 3 times, maybe even 4 times. I'm going to move it out a little bit more. Measure this new distance here, record it, and then I will release the ball a 3rd time. And I should get yet another mark on my paper. Now, I've done it at 3 different distances. As I said, you could do it for 4 or 5. We certainly need to do it for more than 1 or 2. We should find that the horizontal component of velocity was the same at each point. Now I'm going to remove my carbon paper and look at what I have here. And it's very nice. I have my mark of horizontal where the ramp was, and in the first run it hit there, the second one there, and the second one there. So you will take your ruler and you can measure the distance it has dropped in the horizontal for each run, just like that. Very easy to do. Then you have a vertical distance and a horizontal distance for each run, and using our kinematic equations from class, it will be an easy thing then to compute the horizontal component of velocity at impact for each of the 3 points. You should find they are just about the same in each case where you did something wrong. So you should find the horizontal component of velocity is constant because the only acceleration in this case is in the vertical due to gravity. So that's pretty well everything you need to know for this lab, 2-dimensional motion. So we'll see you in the lab room.